else, colon, and this not be there. But this was more of a puzzle than anything else. So in this next one, we have to remember that these things happen in order. So if x is less than 2, we're going to run this. If it's less than 20, we're going to run this. If it's less than 10, we're going to run this. But the problem is all values of x that are less than 10, for which this would become true, this is always true. So a value like 6, this becomes true. So that means that if it's something like 6, it's going to run this and come out and never ask this question, right? So that's the key. Even though this is true and this is true, for the 6, it never even gets here because this one triggered first. Okay? And so that's why this is the line of code that no matter what the value for x, will never run. Okay, so the last conditional code is what's called the try and except structure. And it's if you learn other programming languages, this sort of catching errors is a more advanced concept. But in Python, we tend to have to use it earlier because there are things where if you don't use it, the code blows up. And the whole idea of a try except is that you have a bit of code that you know might fail. And so you kind of want to take out an insurance policy on it and say, hey, give this a try. If it works, great. If it doesn't, do this other thing. Don't blow up. Don't get a traceback. And so this is a way to eliminate or catch a traceback, something that would otherwise be a traceback. That's what this is for. So if you got some line of code and you know that this might blow up and have a traceback, then you use try except around it. Okay? So let's take a look at something. This is a sample we had from the previous code, and it comes down, it sticks hello Bob in, then it converts this to an integer, and we know that if these things aren't digit, this code blows up. And so it runs, and we get the traceback. The traceback happens because of this line right here. But the key thing about the traceback is that the traceback, as I told you before, it stops. And it stopped at line 2, which means this is the last line it executed. But it doesn't continue, which means this code is gone. I mean, it never gets there because it's like, I'm confused, I'm quitting, I have quit at line 2. Okay? I quit at line 2. So that code, it's as if it's not there. Now, sometimes that's fine with you. You just want to blow up and you want to see the message. You want to go look at line 2 and fix line 2, or maybe type the wrong stuff in. But sometimes you want to control for this. You want to say, you know what, I know what I want to do here, and I don't want to die, and I don't want to blow up. I want to continue. I want to put out an error message instead. And so the key is when this code blows up, it's something that you kind of take personally because, you are that set of instructions. And when a traceback happens inside the memory or CPU, that's you that's being vaporized. You've been tracebacked. And so we take it kind of personal. I mean, if you were to use software that I built, like the autograder for this class, and you started getting tracebacks, I'm like, hey, that's kind of a personal thing. I didn't do my job well. I didn't catch all the errors. I didn't think of everything. You could type something that would cause my code to blow up. And so I take that kind of personally. And so we have to be able to compensate for situations that we know might cause errors, especially those where the user can type something that can cause my program to blow up. That's really like, I'm going to let you blow my program up. I am going to compensate. I'll tell you, sorry, that's bad data, but I don't want you to ever see a traceback because it's kind of shameful to see a traceback for a professional programmer. Okay, so here's how it works. It's a bit of stuff with some indentation and colons. It looks like a lot, but don't worry, you'll figure it out. So the idea is you have a line of code that you know is dangerous. So this conversion of an integer, let's just say this came from an input statement. In this case, we'll just make it be hello Bob. We know this is going to fail. And so this is the line in which we kind of want to take out insurance on. So instead of just putting this line in here like we did in the previous example, we just had it right there. Instead of taking that line there, we say, you know what, we're going to take and stick this in a try and except block. So we say the word try ends in a colon, which means it's an indented block of code. And then we put the dangerous line in there. And then we put except. And then the except is kind of like an else, an if then else. But what it really is code that Python will execute if something goes wrong. So this is either going to run and work and skip this, or if it goes bad, it's going to run, blow up, and then run this stuff and then continue on. But in no case will you get a traceback. Meaning if this line is going to generate a traceback, it actually just runs the except clause. So it's kind of like an if things work out, do this. If things don't work out, do this other thing. So in this case, when this runs, this is going to fail because that's hello Bob. And then it's going to come out here and set this to -1. So that's going to blow up. Set this to -1. And that's going to print it out. So it says first equals -1. And so we didn't trace back. In the previous time we ran this, it traced back because we caught it. Now, the way the try except works is if everything is fine, it has no effect. So if the next thing we're going to convert is 123, the digits 1, 2, 3 in a string, we do a try and we try to convert it and it works. And so we just keep on going. We don't run the except. So this code does not run because this code succeeded. There was no traceback that was going to be generated. There's a traceback generated up here. There was no traceback generated here. So it comes through and the result is I_stir ends up with a integer 123. And so it's an insurance policy, or it says, I know this might blow up, and if it does, I'm giving you alternate text or alternate code to run. So the thing about the try except block, and you might be tempted to do this, and that is put your entire, if you're getting tired of tracebacks and blowing up, you might want to put your entire program in a try and except block. And you might say try blah, 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 and then except something bad happened. The problem is if your program is blowing up, you actually want to know about it. And the way the try and except block works is if it's in the middle of a try and except block and something goes wrong, like in this particular line, it doesn't come back and finish the try and except block. It actually exits to the except and then comes out. And to draw this in a diagram, so here we go, we start this thing, we're in the try block, we're doing print safe, doesn't hurt anything. We do this blows up with a traceback, and then that says go to the except block, run whatever's in the except block, and then continue on. What's not going to happen is it's not going to go back up and do this, or back up and try this one again. No, 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 no. Once it gets the except block, there is only one way out to the bottom. And so this line of code never executes. And so that's one of the things we try to do where you don't put too much stuff in. You would put this print statement out here and this print statement out here, and you'd only put one line in the try except block if possible. Sometimes you put a few more lines in there, but you try to minimize. You know what line is dangerous. Print is not dangerous. These two prints are not really dangerous. Don't put them in the block. Because any line in the block, as soon as it hits a bad line with a traceback, it's out of the block, runs the except, and then continues on. So here is a more practical example where we're going to read a number from the user and print out either nice work or not a number. And so we'd take an input statement which stops and waits for us to type, and then we type 42, and then 42 goes into roster, and then we know that this int is dangerous, right? And this roster came from the user, whatever the user typed. And so we put it in the try block, and if it's 42, it converts, and it says ival is greater than 0, we print it out, so it says nice work. Now, we'll run this code again. Okay, we run it a second time, and now we enter something, it says 42, but it's like FORTY. And so 42 is what goes in here. We, as the programmer, had no control over what our crazy user was typing, right? You're starting to be a programmer, and crazy users do crazy things to your poor programs, even if they're only like 7 lines long. So we got 42 coming in here. We know this is going to blow up. This int is going to blow up with a traceback. But that's okay. We've compensated for that, and we told Python, hey, we know that might happen, and if you detect a traceback, jump straight into the except block, run this, set it to -1, and then continue on. So this is the de-indent of the try except block, and if it's greater than 0, we say nice work, but in this case it's not, and we say not a number, and so it comes out with not a number. What's not here is a traceback. There is no traceback in this. That's what we achieved, and it doesn't hurt. There's no, when it works, you don't need, the try except kind of does nothing because the except code, when it works, is ignored. So it's like code you add in case something happens in an other line of code. Pretty cool, actually. So you have a couple exercises, and then I've got some videos of those exercises. So in summary, what we talked about in this chapter is comparison operators, logical questions. Key is that these comparison operators don't change their arguments. You can say if x is less than 5, doesn't change the value for x. We have indentation and how important indentation is. One-way decisions with if, two-way decisions with if then else. Nested decisions where you have an if inside of an if that moves on in, else if, and then try and accept to catch errors that you want to catch. Okay? So, thanks a lot.